So now in this video, we're going to look at a voltage ramp. So we have the capacitor there. We're going to use my pocket oscilloscope right there. There's the black alligator clip going to ground, and then the voltage in relationship to 0 volts right there. We got the red alligator clip to this jumper measuring the capacitor voltage. And it's 8 volts right now. The power supply is 8 volts. So the capacitor is fully charged. And when I press the button, you're going to see that the voltage dropped down rapidly, and when I release the voltage, that is when our ramp starts. So we're charging the capacitor right now with a current source, so it's going to be a steady voltage rise until close to the end. Oops, I did not mean to do that. So let's just watch that again. We got a voltage with a steady rise right there until close to the end. It's going to curve a little bit. I'll try to pause it right on that line if I can. So we have, it's going to be about 1 milliamp. It's a 1000 microfarad capacitor. So with a 1 milliamp of current going into it, it should rise about 1 volt a second. So it's not perfect. It's actually slightly less than 1 milliamp. So you can see it's going down a little bit. But we have a steady voltage rise. That is what a ramp is. And now we'll look at the diagram I put together. So there you can see the capacitor right there. Negative side is going to ground, of course. Positive side, this is polarized. That side needs to be more negative coming up here. And 1000 microfarad, as I said before. If you charge this at 1 milliamp of current, a steady current, you're going to get a steady voltage of 1 volt per second, as we saw. Again, this is not a perfect 1 milliamp, though, even though the component's made for that. It has a tolerance, and this was like the lower end. We were actually getting like 0.88 milliamps, slightly less, as I said before. We saw that in the last video. But in any case, the component's called S102T. The S means that it's surface mount. It's a little component there. They just put it on the board with some solder pads and pins that we could plug into the board. So it's going to let about 1 milliamp of current, and that will charge, again, the 1000 microfarad capacitor about 1 volt a second, since it's a steady current. This is the oscilloscope measurement we took. You can see we kind of got a measurement there of a ramp. I use that to symbolize. That was the measurement we got. So the current is basically all going to go into the capacitor, just a very small amount trickled through the meter. When we close the switch, that shorted the capacitor. It instantly discharged.